So I am coming into this forum with a topic that is probably a little bit different from what you've typically seen. I'm bringing a sort of an outside-in perspective, if you will. From the outside world, what is the perception of the result, if you will, of informatics or computer science? And the fundamental result is a decision or an action based on data, based on some result, usually data at rest, but often data in flight. So the world has evolved quite a lot over the last 40 years, as you'll see from my little tortured path through my career here. There were a lot fewer things going on back in the 70s with computers. It was a smaller world. It was less complicated. We were much more interested in smaller things and smaller results. We've probably grown by 4 orders of magnitude since then in compute capacity, in data storage capacity, and complexity, and the variety of things that we are literally trying to accomplish to make some value out of this marvelous machine. To put things in perspective, about 1981 or 82 was when the Cray 1A, the first supercomputer, was introduced to the market. The laptop on my desk right now is probably about 1,000 times more powerful in terms of sheer compute capacity compared to that machine. And that was the most amazing, interesting machine at the time. So we're looking at a big paradigm shift that's occurred in the industry over these years. I've progressed through a sort of a meandering path in the industry over what is a scary number of years now, 40 years. So I've picked up a few things along the way. I've always been a hands-on practitioner in the sense that I have developed software solutions or been a direct participant in their planning or development every step of the way. So I've touched on a variety of different industries, landing finally at a company called Ab Initio LLC. You've never heard of us, I'm almost sure. If you have, I'd like to know, has anybody in this forum ever heard of Ab Initio? I'm speaking up, so I'm presuming that's no one. Ab Initio is probably the biggest little company that no one's ever heard of. We are a privately held company. We don't market per se. We go to market via word of mouth, C-level referrals, our reputation, and a tiny little bit of networking here or there to obtain new contacts. We were born from what was Thinking Machines Corporation, which appeared on the scene about the same time as the Cray, due to a doctoral dissertation from Daniel Hills at MIT, who proposed a massively parallel computing architecture. Some folks who had money took notice, funded the work, and the actual computer was built, the so-called connection machine. If you've ever seen the movie War Games, it actually appears in the movie. It's the so-called Whopper, W-O-P-R. That computer was a little bit before its time. It was the first truly massively parallel array. I think there were 64,000 CPUs in it, all connected in a massive hypercube network. The product succeeded in the market for a time, but it was displaced by other technologies. So over time, Thinking Machines was not able to continue based on that one specific kind of computing, a proprietary massively parallel architecture. So the company evolved into something else. It was the principles and the principal knowledge obtained from building these parallel computing engines was translated into a commercial setting. So Ab Initio, which means born of first principles, came about by taking all of those principles that they learned and trying to come up with a solution that people would pay for to solve business problems at scale. That's our core motivation, is data processing at scale, but a wide continuum of products have come about over the years. We're 20 years old, 25 years old. We have some very relatable projects which you've never heard of. For example, we settle all of the clearing that takes place in the New York Stock Exchange every day. We do the point of sale fraud detection for American Express, Citibank. We do the point of sale for Home Depot. These are high volume, real time transaction processing systems. The Citibank fraud detection is a real-time rule management system that uses scoring models to be able to determine whether they think this is a fraudulent transaction. We have built highly scalable, responsive systems for telecom providers that deal with billions of events per day. Fortune 500 is pretty much our customer base. So just name dropping left and right, Blue Cross Blue Shield, every major US insurance company, every major US bank, FedEx, Southwest Airlines, and internationally, all the suspects you would think of there. It's a wide footprint for a very small, somewhat secretive company that we are sort of known for that. We don't really show off our technology or our key intellectual property in conferences. We don't write about it a lot. We basically go to our customers, ask them to give us a hard problem to solve, and then we come in, install our software, make it work, usually takes a few weeks, and leave it with them for about 6 months to a year while they try it out. It's the try before you buy sales model. Generally speaking, the result is something they can actually use. So that's essentially our whole story in a nutshell. If you want to know a little more detail about sort of the foundational elements of the technology, the Wikipedia page is actually a very good overview of the cooperating system, the components that we built out on top of. It doesn't tell the whole story today about some of the larger solutions like the one that I work on, the Metadata Hub. That little graphic you see in the lower right-hand corner is a screenshot of our programming language, the graphical programming environment, the GDE, which implements a data flow programming paradigm that can be scaled across platforms, both horizontally and vertically, meaning you can scale a component or you can spread the components across multiple machines. So when I joined the company, I knew nothing about data flow programming. I had never seen it. It's not a popular or a common concept, but now you see this evolving in the industry with big data solutions. There's a notable number of them coming from the Apache Foundation. I'm trying to remember the name of it. Cassandra comes to mind. There's others. So we're now a bit more relevant than we used to be in this term of scalability. Going back to the foundation of the company, we are founded from first principles. So that's part of our culture, and you'll see that being the backbone of this presentation today. What we're going to talk to primarily is the scope, range, and size of data governance, the whole topic. This is a sort of a survey of the outside world looking at IT and looking at data. From our perspective, we sort of begin with something Carl Sagan rather humorously illustrated with this famous quote: if you want to start from scratch, first you have to create the universe. Well, we take a step back from that and say, first you have to define your principles, and then you can create the universe. That actually is a foundational plank of what data governance is all about, and I'll tie that in as we go a little bit further forward. But our basic credo is to solve the right problem. That's challenging sometimes to go back and determine the real problem that you're trying to solve. It requires a lot of discussion, and frankly, it makes for some very interesting and sometimes vibrant lunchtime conversations, because intelligent people gathered in the same room can generally agree to disagree on what the real problem is. Our philosophy here primarily, and I'm speaking mostly in terms of how it informs the whole idea of data governance, is based on you cannot control what you cannot measure. It's a fundamental axiom of statistical process control that was introduced by the father of statistical process controls, J.W. Deming. I love his other quote, which is absolutely very, very true. Without data, you are just another person with an opinion. And that is so very true, especially when it comes to navigating where to find things that are true. If you don't have a map that's true, a map that you can trust, you can't find things that are true. So Marie-Louise Saugestette, I think is how you pronounce her name. I found this quote on the internet, so I can't claim to know who she is, but I thought it was a very accurate depiction of part of the problem that we face. How do you draw a map? How do you draw a map that you can trust? Finally, if you have something that produces some degree of agency over a result, a computer calculating a result, calculating something and delivering it to you, you can't really trust it unless you can see where that result came from, unless you can trace it back. So J.K. Rowling captured that in a nice quote: never trust anything that can think for itself if you can't see where it keeps its brain. The other quote from Hogwarts is excellent in terms of framing the problem of data governance. Never tickle a sleeping dragon. And what we mean by that is don't make career-ending mistakes, anger regulators, invite lawsuits, damage the brand by making catastrophically wrong decisions, and then count on the fundamental axiom that basically people are flawed. They produce inconsistent perspective when they are basing their rendition of a fact based on something that's really their opinion. And that's really the fundamental problem, is how do we gather truth? How do we find trust in data, in the results of a computation, in the results of a system, in the results of an approach to deriving something from a computational engine, which is the essential essence of what drives our industry. Money makes the world go round. For us to cash our paychecks, a lot of this work that we do in informatics, in computer science, in systems engineering, in application development, in applied computer science, in applied math, is to produce some kind of economic result. And that result has to have some degree of systematic consistency, i.e. trust. So the foundational plank of data governance is really learning to trust data. And the only way you can really trust it is to quantify and measure and control qualitative aspects of data. It has to be systematic. It has to be repeatable. It has to be something that you can do over time and chart out so that you can see whether your influence over those attributes of quality is having any impact at all, or whether you need to address something that's gone awry. Data quality per se is a measurement of some qualitative aspect of data. So there are contextual measurements. For example, is this data fit for the intended purpose? How accurate does it have to be used in this particular context? Or it can be context-free, meaning it's intrinsic. It's got its own internal qualitative attributes that can be measured independently and outside of any other context, i.e., is this record complete? Does it have all of the data that it needs? The frameworks for thought for this are all over the place. You'll choke yourself trying to sort them out and figure out which one's better. The one that comes to mind immediately in terms of any sort of statistical process control is Six Sigma, which has been around for a while. I didn't put any references on this slide, but if you Google Six Sigma, you'll find more than you want. The Wikipedia page is excellent. It describes it quite well. It's a very mature framework of thought for using a sort of a scientific approach to measuring, altering, measuring change. The handy keywords are DMAIC or DMADV. People toss them around a lot, but basically they illustrate that flow process that you see right there to the right, which is to define, measure, analyze, change, redesign, improve, and then control. That's basic flow of any kind of IT or computer solution. Computer science in general is about determining how to go about using computers, how to do things, algorithmic structure, architecture, means of computing. But it doesn't necessarily speak to what you do with it once you've built it. And qualitative measures are how you measure what you can do with it. Data governance is an outgrowth of that thought, meaning data are now really a valued asset. They're something that actually has quantifiable value. In business thinking, which is really all about getting some stuff and making something else and selling it for more than it cost you to make it, everything else is details. Managing those quality aspects, managing those parts that you use to make stuff is an asset management paradigm. So in enterprise management, in business management, this is a very well-defined domain, generically speaking. It's a partition of the operation of a business, governance of the assets of the business. So it only takes a few words of change to alter the definition, which I scraped right out of Wikipedia, to make this data management or physical data asset management or data governance. It's all pretty much the same idea. So governance is really sort of the foundation of affordability, availability, integration around data. And from that spans out all of these different domains. But primarily governance is about controlling, managing, inventorying, locating, et cetera. Same sort of thing you see in government. In the industry, there's a variety of dynamics that have spun up in this space, most of them in the last 20 years. Some of you may recall a particular event that took place in 2008, which was essentially financial Armageddon. The entire financial market around debt and risk collapsed around a kind of a house of cards built around risk. A great deal of expensive reaction to that occurred, which produced two outcomes. One, it kept us from going into what is arguably a Great Depression. It was that big an event. We were really seeing something of that size, an extinction level event. Secondly, what it did was cause the regulators to come in and kind of assert their ownership over what banks were doing incorrectly. In other words, the banks themselves were the core problem. They were not really aggregating and reporting the risk that they'd exposed themselves to, which is therefore subject to some regulatory control. For example, you have to keep a certain amount of capital reserves in a bank to cover your projected losses. What are your projected losses? That's based on risk. What are the credit ratings of the people you've lent to, et cetera, et cetera. BCBS 239 was the outgrowth of that, which provided a series of what are, in the Pirates Code called guidelines. But in practice, regulators can go fine banks for not accomplishing what those principles require. And that has been happening. It's been happening increasingly with larger numbers. The most notable one most recently was Citibank being fined $400 million for not following those principles after they had been warned that they had to by the SEC and the FDIC. So there are real things happening out there now, consequences of not managing data, of not governing how you use it or measuring it. Separately, GDPR in the European Union and in our country, the CCPA, the California Consumer Privacy Act, and then subsequent acts like the Virginia Privacy Act and others that are modeled on it, are now establishing frameworks and consequences for how companies use personally identifying information. PII is information about you that can identify you, your name, your address, your social security number, your credit rating, your bank account number, your phone number, your email address. All of these things are considered, your birthday, your things are considered PII. That's how credit identity theft occurs. We've known in the news of many hacks. Experian comes to mind as maybe the biggest one, but there's Target, there's Home Depot, et cetera. But the biggest dog in the room that inspired this law was Google. The GDPR is often called the Google law, and it's in part designed to implement the right to be forgotten, meaning that you can tell an enterprise to forget everything they know about you. And there is law now behind that, which is enforceable. And the EU has been meting out fines now to Google, Facebook, other big ones who are misusing personally identifying information. So now we have this problem. How do you locate it? How do you verify what you're using it for? How do you validate that a customer who's asked to be forgotten has been forgotten? How do you tell a customer on request what you're using their data for? These are all now written into that law. So this is part of the governance remit, which is to be able to answer those questions. There are standards that are forming. ISO in particular has some very nice documentation in 11179 and others that give great models for metadata, great models for structuring the language of collecting information about information. Industry research is spinning up. Gartner, Forrester, our good friends out there who basically tell us what to buy in the industry, are doing what they do, which is to create a common vocabulary around how to measure the solutions in those spaces and metrics and attributes of those solutions that customers can then use to create RFPs, RFIs to measure the industry provided capabilities and weigh them. It's what I call a beauty contest. That's essentially how these work. Unfortunately, Ab Initio will not appear on any of those because we don't participate in beauty contests. And that's part of our culture. We prefer to just go in and show you what we can do. And that should give you enough confidence that we are who we say we are and that we do what we say we do. It's just against our grain to go out there and kind of go for the lowest common denominator. We just don't really want to do that. Then there are industry organizations, as they always do, spin up around this, trying to create common bodies of knowledge. The DAMA, Data Management Association, the EDM Council, which is at a more C-level, have all tried to address this by collecting and presenting knowledge on the web, the most concrete of which is the DMBOK. If you're familiar with project planning, there's the PMI, Project Management Institute, which famously created the so-called PMI BOK, the Book of Knowledge, Body of Knowledge. Well, that has caused everyone else to have to create a body of knowledge. And now the DAMA has the DMBOK, which is actually a very useful reference in terms of having a wide and well-defined vocabulary of data management. It talks to everything. It talks to governance, it talks to semantics, it talks to classifications. It's a great framework of reference that gives you essentially an industry vocabulary over this entire space. I'm very attached to that particular reference as a way of normalizing language when we go in and talk about fuzzy words like data governance. Data governance is a misused term. It's misunderstood because it operates at multiple scales. One size simply does not fit all, and the prioritization of what you focus on has very different drivers depending on what the industry is, what the risks are. What you see here is essentially a kind of an obvious breakdown from McKinsey. That's sort of what McKinsey does, is they frame things for management purposes. What they're basically saying, though, is that the more risk, the more regulation, the more consequence, the more you have to govern. The higher the complexity, the more difficult it is to govern. These are two essentially opposing irresistible forces. So there's a natural tension to the evolution of this space because of that. The solutions for implementing data governance, data management, et cetera, have to evolve with the complexity of the space and the scale of the space, which is exponential. The size of the data growth and the complexity of data growth in the industry is geometric. So scaling a data quality solution, scaling an ability to scan data lineage is key to being able to deal with high levels of complexity. Being able to respond to that challenge, to deal with existential threats to your business from regulation, fines, lawsuits, et cetera, is the driver for adopting those solutions and putting them into place. So this space, data governance, if you will, data management underneath it, have quite a bit of momentum that's driven by economic reasons, not because it's sexy or because it's the latest buzzword in the industry. That, of course, is true. But there are actual real dollar consequences driving these investments. And coming back to this forum, and why does this matter to you? You are the dreamers of dreams. You are the makers of things. When you come into IT via computer science, you are tasked with producing stuff, data, the result of your effort. What you do with that data matters. It has consequence. How you do it, how you store it, has consequence. The individual developers are no longer unaccountable for the names of things, for the semantics of things, for documenting what they do. They are now held to a higher standard of being able to explain it to people that are not technical. So that will be your challenge going into your careers and coming out of the world of study. You will need to be able to do these things. So this will impact you to some greater or lesser degree. At the least level, it will impact you in the sense that you'll need to be able to document and explain what you've accomplished and how it works so that the governance process can assess it, can assess its risk, can inventory it, can measure it, can monitor it. That is all going to be part of it, especially in data science, especially in deep machine learning, which is basically suffering from the most difficult problem in data governance of all, which is to validate the result to make sure that you're not getting bad results. So organizational approaches to this in the industry, particularly in large enterprises, particularly in IT, the organizational shape generally breaks into 3 layers. You will see at the lowest level, the domain that is generally referred to as data management, and that's a pretty well understood term. In industry, what that basically means, it's the keepers of the systems and the keepers of the databases who are implemented with operating them, controlling them, managing change over them, et cetera. Other groups in the past were database management groups. They would marshal the databases and control them and so on. That's evolved into an actual domain, which is broader than that, that includes things like managing reference data. implementation of systems that manage reference data, etc. They are the actors, the data economy. They're the people that carry out the work, seek the goals by actually implementing objectives. They are the boots on the ground people that do the work. Data strategy is essentially a plan to get there. It's how are we going to accomplish something? This is essentially the executive level of governance in a government. In other words, we are going to set the policies, the standards, the processes, the platforms, the technologies, the capabilities. We're going to choose the applications. How do we securely affect leveraging data to meet business objectives? The lowest cost for the highest value, the strategic advantage, the ability to do something that no one else can do. Those are all parts of the business thinking that define strategy, the how of getting to a place that you want to be. Data governance is essentially the legislative oversight of strategy and management. It defines the programs and processes. It is accountable to monitoring integrity of those processes. It is the executive, AKA senior executive in business speak, or the elected representative level, AKA representatives or senators in Congress, who write the laws that are setting strategy, that they set direction. The key point, though, is that across this whole spectrum, enterprise data, strategy, governance, all of it is not a democracy. I'm drawing a parallel to government, but that's not exactly correct. It's more of a benign dictatorship. And there has to be a degree of control downwards and measurement of result of that control going back upwards to steer and get somewhere. That's what business management is responsible for doing, which is modulating investment and using it to grow a strategy. The principles that are behind data governance are fundamentally about trust, as I mentioned before, but the method has to fall out of the data space. How do you do this? How do you accomplish it? Well, the first and most foremost requirement is that you be able to identify or define the important or the critical data assets, to enumerate your assets in the enterprise. This is the first fundamental plank of any business asset management paradigm. You have to stick an asset tag on something. You have to be able to identify it, to count it, to count how many of them that you have, etc. And then the rest is all more or less sort of a derivation of that space, meaning you create policies for data and for data processing. You define the indicators that ensure those policies are being met, AKA data quality. You implement processes, meaning repeatable, integrated, systemic processes to generate those indicators. You assign people, owners and operators, to manage that process. You establish goals for that process to reach certain levels of quality, to reach certain levels of accomplishment, and then you report and track against those goals. How are we doing? The key term, so beloved of senior management, is a dashboard. How do I steer this airplane? How do I run this car? I need instrumentation. I need to be able to read it. I need to be able to see where we've been and how well we're doing and how much fuel is left in the tank. How much do I have left to do? Am I complete? Do I have velocity over my business work assigned to actors who are carrying out the work? This is not really the kind of paradigm I alluded to earlier in terms of statistical process controls, but it is cut more or less from the same cloth. This is all basically a data, meaning informed management process over change and over collecting and collectively asserting agency over valuable assets in the business, in this particular point, data. So what does that really mean to quantify or identify data? Well, what that really means is you're creating a sort of a quantum of identity. What is the lowest amount, the smallest amount of information I can have about the smallest unit in my universe? In physics, it's a measure of energy. Quantum in computer science is often referred to as the smallest amount of time a scheduler in an operating system would allocate to a process. In data, it means an atomic unit of data. A field, for example, in a database. It is a kind of a periodic table of data elements. What are the different data elements we have out there? Birthday is a data element. That can be a single field. That could be 4 separate fields that are collectively a birthday field. So what you're doing is you're essentially creating the universe of data, the fundamental elements of data that make up the universe. So you have these parts of it, you could call them in conceptually the subatomic particles that make up a atomic element of data, the things that sort of located in the fabric of reality, taxonomies that help classify it and hierarchies that help classify it, definitions, terms, locations, rules, policies. All these things are essentially elements, a multidimensional coordinate of what makes up a specific data element. These coalesce around that to form a specific concept, which we kind of colloquial in this world, in my business, in my customer continuum, refer to as a business term. What a business term is a definition of a data element. It's a glossary term. It's a name, and then there's a description, and then there's all this stuff, all these attributes that you collect around it to give it some more and more precise identity, more and more precise set of semantics that govern it or that say what it should be or where it is or where it fits into the continuum. On the surface, this becomes what people refer to kind of generically as metadata. And I kind of hate that word because it's a bit of a Rorschach test. When you walk into a virgin environment, everybody thinks they know what it means. So it's a Rorschach test for whatever you want. It's in your context that you can define what you need that you don't have. So when I've conducted customer workshops where we're trying to nail down some specific use cases or requirements of what they're trying to do, my entry speech in that is to forbid the use of the word metadata. You're not allowed to use the word. You can use any other words to describe what you want, but you can't say, I'll just go look at the metadata. You have to define the use case. That actually provokes a pretty interesting kind of discussion because you've taken off the table the one escape hatch for having to be precise, for having to elaborate, to ab initio, to define the principles, to define the purpose of your problem, and then explain your problem. Instead, a lot of people who get to use that word will simply retreat behind it and say, well, we'll just put that in the metadata. But they haven't really defined what they're trying to do. They haven't really defined why. And then those kinds of projects spin out of control. Metadata then is information, knowledge about information. This is not a new subject. Metadata has been a concept coming from library science for generations, going back 50, 70 years. It's a fundamental part of classifying information. So some years ago, 2016, there was a very, very nice article that defined what they call the FAIR guiding principles for scientific data management and stewardship. These principles are sort of universal in the sense that they define what should be in terms of metadata. It has to be findable, it has to be accessible, it has to be interoperable, it has to be reusable. And then it breaks it down, and the article's great. There's the reference. It's worth reading. The flaw, as in most things like this, is that it's essentially a utopian ideal. And yes, all of these things are what metadata have to be useful within an enterprise. This article was written more about scientific data that's shared across domains, especially across the internet. It makes a very big case for how these things need to be open standards based on ISO or other nomenclature, other ontologies that define how you define data, et cetera. There are rigorous specifications out there for that that are part of the scientific community. The reality in the business world is that there's absolutely no desire to share this across businesses. You rarely find a common vocabulary. Sometimes you do, but for the most part, businesses develop their own colloquial vocabularies. Metadata then become closely held within an enterprise. And the solution that's evolving around it, around capturing it, around storing it, around curating it, these are software solutions, of course. These are all proprietary solutions using proprietary models. There is no real common industry standard. There are meta models out there. There are meta models out there. There's some pretty good ones, but they're generally considered ways to move data across vendor solutions. You'll rarely see a vendor solution that's built to some kind of internal standard or canonical standard of metadata management. We have one, of course. We think it's the best. Ours is built into our product. It is a proper canonical metadata model or a meta model. It's normalized, so all of the data that comes into our product falls into this one kind of common enterprise model for metadata. But We don't share it with anybody else. You have to sign an NDA to be able to use it. We open our database so you can query it. So it is findable, it is accessible, it is interoperable in the sense that you can extract the data, and we do have a standard within the product. It is reusable in that the metadata has a plurality of accurate and relevant attributes. It's released according to a license, if you will, blah, blah, blah. All of that's true within our product and within the other competing products as well. But the box exists within an enterprise, and it's usually unique to that enterprise. So what really can you do with metadata to make it sensible to a sort of a broad audience? What's the horizontal concept of it? Well, metadata fundamentally is organized by a taxonomy, much like in biology. There's a fundamental root, which is broken down into high levels of abstraction, business, technical, operational. Those break down into more specific kinds of metadata, logical models, reference data, models of people, meaning organizations or owners and stewards, data dictionaries, which consist of business terms or business term groups, code mappings from terms to specific encodings, lists of valid values. Hierarchies, in particular, organizing metadata, are themselves forms of metadata. So inventories of systems, inventories of applications. Those are two particularly fuzzy terms, by the way. No one will have the same definition of what a system is or what an application is from one company to the next. But these are abstract, kind of object-oriented root objects of metadata. That's a good paradigm here. A system is a kind of an abstract class in an object-oriented world. So is an application. An executable is an abstraction of something that takes data, morphs it into something else, and lands it somewhere else. That's how our model is built, is around those abstractions, and then we refine those abstractions into specific instances that are sometimes very technology specific. But the one commonality across all of it is, it's all about organizing who created it, uses it, manages it, particularly what it means when it was created, updated, or used, when it was computed, how it was created, where did it come from, what was the method, what was the calculation, how does it relate to other information or data or metadata, how do I obtain access? That's a lovely part of this space, which is becoming increasingly important in this world of hackable mobile data that's very dangerous or very valuable. Think about the little thumb drive that you often use, plugging it into a computer and downloading the entire Southwest Airlines frequent flyer list with all their personal identifying information or something like that. So obtaining access, security management over that is actually part of the metadata remit. How do we define the policies for access? How are those policies enforced? How do we validate that they're being enforced? And all of this changes over time. The definition of a field, the definition of the attributes you want to collect around a field. That's a moving target. It evolves with the technology. It evolves with the maturity of a customer. At JP Morgan Chase, they have some 50 some odd attributes that they've defined around their critical data element definitions, meaning that one business term carries 50 separate attributes that they've collected over time, over the evolution of what they need to know about a critical data element. Most customers that come into this space, from my point of view, I use the word customers because that's what I work with, do not have such a mature point of view. They're much more basic in their approach, and it evolves over time. So versioning of things, being able to look back in time to see how it was then, data lineage in particular, is exceedingly important. So when I talk about these things, what is the actual fabric of reality that I deal with in this world of data governance and in this world of data management and in this world of standing up solutions to affect that in an enterprise setting? Well, the most obvious one that comes to mind is the structure of data. So this is just one illustration. It's drawn from an SAP product called Business Data Warehouse. This should be a very kind of obvious example to those of you that have studied data warehousing, which is basically a star schema. Fact table, dimension tables, and then the attributes of each dimension and so on, to form a way to report data and aggregate it across multiple dimensions. That's your typical data warehouse. There are many other structures. The vast majority of them in this world today are defined by relational modeling tools like Erwin, data designers, et cetera, that use ER type modeling or OO type modeling to some sort of data model All it really is capturing, the commonality of it is structure and relationships. So analyzing that and producing it in some common way is the challenge in the metadata world, which is the mill or the fabric of reality for the data management mill, which is the driver for defining policy and implementing quality controls over data. So it all goes uphill in terms of starting in the basic levels. What is the structure? What are the relationships of data? In terms of acting out this process, it's really ultimately about people and assign accountability to action or agency over specific types of change or gathering information, acting to it within an enterprise. So what you're seeing is essentially a screenshot from one of our products where we have a critical data element called exposure value. It's been defined as a risk domain associated with it. It comes from a particular business. But we've assigned people with faces and contact information to be able to own aspects of that data atom, that critical data element, which is an abstraction. One of them is business owner, the guy in the business that's particularly interested, the stakeholder, if you will. One of them is the data steward, who's responsible for sort of acting out agency over this thing as it changes over time or as changes need to be applied to it. And then there's the technical subject matter expert, Horace B. Neville. And the on the left is more intended to point out the fact that people with faces in roles are the people that you talk to and work with that actually do things, individuals. People as a class, as an abstraction, generally don't act with responsibility. There's no one in an abstract group of people or people within a class of people carries any specific personal responsibility. So accountable parties are individuals who are responsible, who will be held responsible for things. And that is one of the keys of this space, is that you have to assign and then validate and oversee agency carried out by responsible individuals. Otherwise, you have no way to know whether something got done or whether something will get done. People.
Larry, I don't mean to interrupt you. Just again, I'm just going to interject for a moment. So I'm sure you want to leave a little bit of time for Q&A. So we normally don't go beyond 1 hour, and it's all about 10 minutes before the hour. So just give you a heads up on that.
So I will rapidly go through the rest of these slides. I won't talk quite so much. We can just read. People, boots on the ground, data analysts, data scientists, business analysts. These are people that work with data primarily. The other types of parts of this story are data lineage, meaning data provenance. How did we get from point A to point B? This is where my rubber meets the road. This is how we scan, reposit, and then report on data for the purposes of data governance. And what you're seeing is a screenshot of a program that was into our product, the Metadata Hub. This can get exceedingly complex. This was actually a result of one of my engagements 10 years ago. Teradata at Intel with approximately 100,000 tables and views, et cetera, et cetera. And that's just the leading edge of complexity. This is the SAP Business Data Warehouse complexity, which was at least an order of magnitude larger than that and formed one component in the landscape of data at Intel. Data usage, keeping track of who's using data for what. This is the model that we developed for them to track consumption of data. People versus applications, who's using what and why. All of this becomes very important when you have data as a kind of a volatile substance that can blow back on you if you make the wrong decision. And there's a nice story on the bottom of the slide about how data was misused. And that comic was essentially the reaction they had when things went wrong. How does informatics figure into this space? How do computer science and other things affect this space? For the most part, it's about automation. It's about algorithmically deriving knowledge from scanned or harvested knowledge, different changes, automating data, reducing technical lineage, blah, blah, blah. Some instances of that are data quality systems. This is one. A model, essentially state changes in workflow, systems collect and react to events. Business lineage, meaning an interpretation of detailed physical lineage, particularly with regard to determining the veracity of a source or a conclusion. Is this really true? Did you really do this? Can I rely on this? Business data derivation, meaning the calculations that take place along a data stream. All of these things are instrumental to controlling the law of unintended consequences, meaning somebody modifies somewhere, what could go wrong in that space? So we need to place controls, we need to validate things. Locating controls is part of the physical fabric of this world. So finding the place to put the instrumentation and implementing it is part of reading the map to know where the strategic places are in that space. And then finally, in the future, where does this lead us? Again, it's all about automation. I'm going to leave us here on this slide. I'm going to open up the call to questions and discussion. Thank you, Michael, for the time check, because I do get carried away.